I'm Marc Levitan with the National Institute of Standards and Technology. I'm a wind and structural engineer in the structures group. So as a wind engineer, we study wind effects on buildings and infrastructure. So that means effects from hurricanes, tornadoes, thunderstorms, and other types of severe windstorms. A tornado is Mother Nature's most violent storm. It's a rapidly rotating column of air that can be anywhere from, say, 10 yards wide up to sometimes the bigger ones are a mile wide. Tornadoes occur all around the world. However, in the United States has the most frequent tornadoes and has the most intense tornadoes compared to any other place on the face of the planet. Tornadoes are rated on what's called the Enhanced Fujita scale, and they're assessed by evaluating damage to different kinds of buildings. The Enhanced Fujita scale rates from EF0 through EF5, EF0 being the lowest intensity, and that's going to be modest damage, like maybe damage to branches of trees, maybe gutters coming off of a building. The other end of the scale is EF5. That'll have our highest wind speeds. And at that point, except for the most well-built homes, the home will be completely destroyed, and maybe even there won't be even any debris left and just the slab left. Tornadic winds are very different from all other types of winds and windstorms we have, and the characteristics that we need to design the buildings for are very different. They have greater wind speed near the ground instead of aloft. They have a vertical component which creates extra uplift on the roof. And they rapidly change in wind speed and direction. In a tornado, the wind speeds are actually highest near the ground, and they decrease with higher height above the ground. That's the total opposite of what we have in our regular winds, where we have pretty high winds, usually at the top of the skyscraper. With tornadic winds, as with other winds, we see oftentimes the most common failure is failure of the roof. In any kind of a wind, as the air accelerates to go over the roof of the building, you get some uplift pressure. In a tornado, in addition to the aerodynamic effect, you also have the suction as the air moves up and you have the updrafts inside the tornado that creates additional uplift inside of the building. The key thing to prevent the roof from coming off is you need to have what's called a strong load path. So that means you have to connect all of the pieces all the way together from the smallest element on the roof, each individual shingle on the roof, all the way down to the foundation. And so that's been a missing hole in our building codes and standards, is we haven't had requirements for design of conventional buildings to resist tornadoes. In the latest edition of what we call the Model Building Code, that's the 2024 International Building Code, for the first time now they have included requirements for design of certain buildings to resist tornadoes. The tornadoes that we're designing for are typically sort of EF0 through EF2 intensity, and that encompasses about 97% of all tornadoes. Now, those requirements apply to certain structures and types of structures in the community, what we call risk category 3 and 4. Risk category 3 would be things like schools and nursing homes and high occupancy buildings like theaters. Risk category 4 is a lot of our essential facilities, fire, police, hospital, EMS. So those buildings that require a higher level of design for other hazards in the building code, they now are also being required to be designed for tornadoes. If they're more likely to survive the tornado, then they're more likely to be there to help in the response, and they're more likely to help to be there to support the recovery. We still have a lot of work to do on tornadoes, as well as states and communities want to start to adopt these new tornado load requirements, and they have questions. And so that means providing support for state and local communities to be able to better understand and better adapt and use those tornado load requirements that are in the model building codes.